Hello and welcome to another video on energy. Specifically, we'll start talking about what is energy and potential energy. Last video we talked about work and how it's measured in joules. However, the unit is about energy, and if you Google, you'll commonly see that joules are a unit of energy. So, what is energy? Energy is the capacity to do work. If something has energy, it can do work. If something doesn't have energy, it can't do work. In physics, we typically talk about the joule as our unit of energy, which is, again, 1 kilogram meter squared per second squared. But you're familiar with a different unit of energy, and that's the calorie. Okay? When you eat food, you gain calories. Those calories you burn and consume allow you to move, allow you to do homework or not. It is what allows you to be active and do work in the physics sense or in the real sense. So energy is the capacity to do work, and it comes in many forms. It's could be potential energy, it could be kinetic energy, it could be thermal energy. But like money, these types of energy are just different ways of storing it. You store your money in the bank, you store your money in a checking account, you store it as cash, as coin, you send it or move it around via PayPal. All these are still money, they're just in different spots, different ways of storing it, and that's just how energy is. We're going to focus on potential energy today. Potential energy is the stored capacity to do work based on its position, based on where it is. In other words, given the right circumstances or push, it can potentially do work. The archetypical example is a book on the ground. On the ground, there is no chance for it to move or displace or have a force act on it over a distance. But this book on the table does. It has the potential to start moving. It has the potential for gravity to do work on it if it falls off. Because it is above the ground, it has the potential to do work. It has potential energy. This is what we refer to as gravitational potential energy. This is the energy that is stored in an object based on how high it is above the ground. So in this case, the blue book or box is on the ground. It has no gravitational potential energy. Whereas the red box is above the ground, it has some energy stored. Now, because gravitational potential energy is based on height and the amount of force it can exert, the amount of energy stored as gravitational potential energy, which is typically notated as PE, or if you want to be specific, GPE, is M times G times H. Mass times G times H. Now this only works if you're close to the planet. If you start talking on scales larger than near the surface, we have to go use the big gravitational force equation and talk about that. For the scope of AP in this class, we will not be doing explicit calculations with that, but do keep that in mind. So if we wanted to know the gravitational potential energy stored in this book, we just need to know its mass and how high above the ground it is. This one has a height of 0, so just like we'd expect, height of 0 gives an energy of 0. A typical other notation you might see, especially from me, is EG equals mgh. Much like force gravity, energy gravity. Same idea, same calculation. The second type of potential energy that's typically talked about at this level is the elastic potential energy, where the amount of energy stored in a spring or a stretchy object. The archetypical example of this is a bow and arrow. If you have just a bow and arrow just sitting around, it's not going to do anything, but if you pull back into form and stretch the string and bow, the amount of energy stored will then have the potential to do work on the arrow, launching it forward. The problem here is, unlike with gravity, the amount of force exerted by a spring or stretched object notably varies based on distance. In fact, you might remember this graph where the force would increase based on the stretch. So how much energy is stored? What is the spring or elastic, is the common term, potential energy? I will typically use EEL or EE for elastic. You will occasionally see EPE, elastic potential energy. I prefer this one personally. How do we calculate that? How do we know that that is? Well, it's force and distance will give us what we want, but the amount of force varies. So if we look at this,
We see forces on the y-axis and stretches on the x-axis. So we can do the same trick we did with displacement and velocity graphs. Multiply them together, find the area. This makes a nice triangle, so we can do that really easily.
if we get to take the force times the stretch, which is F times X, and multiply them together, which we have to take a half because this is a triangle here, we'll get the amount of energy stored in a spring. We can even go a step further because we know the force of a spring is kx by Hooke's law. So the amount of energy stored in a spring is 1/2 k x squared, where x is the stretch and k is the spring constant. Now, this works for springs and any deformed object. This is the primary other way we'll talk about stored energy in this class. Okay, let's take a look at how this works. These are pretty straightforward calculations. These are pretty straightforward ideas. So let's do some calculations. Here we have a ball. It's going down the stairs. Each step is 0.5 meters, which gives you a total of 4 meters. At each point, A through F, what is the gravitational potential energy stored in the ball? Go ahead, give it a try, check back when you're done. If you went through and did your math, you should get these numbers. It's fairly straightforward. All you need to do is take the mass times g, which is 9.8 since we're close to the surface, and multiply by how high above the ground you are. You'll notice that it decreases as you go down in height, and at the bottom, you have 0. One of the interesting observations that comes out of this is that regardless of where you are, if you're the same height above the ground, you'll have the same gravitational potential energy. It wouldn't matter if you're on the
Second step from the top.
or falling from 3 meters. You'll have the same gravitational potential energy. Anyways, thanks for watching. Have a good one.